We have to use truth table to determine whether the argument is valid or invalid. First, we have to write our argument in symbolic form. So we have Gabi will not go on the cruise if she buys a house. Gabi went on the cruise, therefore Gabi did not buy a house. So let's put that Gabi will not go on the cruise will be our first simple statement because we have not. So I will put that this is not Q. So let me circle this with. This is our first simple statement and will be not Q because we have will not negation of Q. I can write that Q is Gabi will go on the cruise. Next we have simple statement she buys a house. This will be our P statement. And next we have Gabi went on the cruise because Gabi will not go on the cruise was not Q. So Gabi went on the cruise will be our Q simple statement. And we have therefore Gabi did not buy a house because she buys a house is our P. So she did not buy a house will be our not P. So now we can rewrite our argument in symbolic form. We have first conditional statement we have because we have word if. If she buys a house, Gabi will not go on the cruise. So we have to start from this part. If she buys a house. So we have P implies Gabi will not go on the cruise, not Q. This is our first premise. Next we have Gabi went on the cruise. So this is our second premise. And we have word therefore, so we will underline our premises and we will put 3 dots for word therefore. And we have Gabi did not buy a house. This is not P. We have our argument in symbolic form. Now we have only P and Q simple statements. So we will have 2 to second power. It means we will have 4 rows, 4 combinations because P can be true or false, Q can be true or false. I use for true 1 and for false 0. In some books you can find T for true and for false F. I like 1 0. That's why I use this symbol. So next we have to build truth table. We have simple statement P, Q, and we have negation of Q. So next will be negation of Q. First premise we will put next. This is conditional statement. P implies not Q. And the second premise is next. This is Q. And our conclusion, I forgot to write. This is conclusion. This is not P. So we have true, 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 false, false, true, false, false. We have 2 simple statements. It means we have to have 4 rows. We need to have for P true, 2 truths and 2 false. and the same for Q. Next, we have to write not Q. So we have to look in the second column, not 1, so it will be 0, not 0, so it will be 1, 0, 1. We have conditional statement, and we know that conditional statement is false only when true implies false. So we have P and not Q. So we have true implies false, so this is false. 1 implies 1, so it's true. 0 implies 0, so this is 1. 0 implies 1, so this is 1. Next, we have to copy Q, because second premise is Q statement. Simple statement, 1, 0, 1, 0, and we have negation of P. So not 1 will be 0, not 1 will be 0, not 0, so will be 1 and 1. So we have our truth table. Now we have to check our premises. We have true premises in the third row, and conclusion is also true. Because conclusion is true, premises are true, it means that our argument is valid. If conclusion is false, in any row in which all of the premises are true, the argument is invalid. In this example, premises are true and conclusion is true. So this is valid argument. This is my solution.